plt.plot, and then plt.show, and we can go ahead and see that this is a bar graph. But it's kind of misleading because we don't start at 0, and it looks like Thursday has a huge spike, but is it really as big as the graph is telling us? Because we're starting at 7,000. Maybe we should change the limits to set this starting at 0. So the quick way to do that is just say y lim, and then just set the first number as 0 and the upper number as 1500. So now it will set the y to 0 and 1500. So it should be a little bit more stable. So yeah, it was not that big of a spike. It's still a big spike, but it's not as big as we thought. So it looks like Thursday 3 is actually where our time between sales increased the most. So that means that was our slowest day, whereas Wednesday was actually our quickest day. So this is sort of the process of data analysis. One question leads to another, it leads to another, and then you keep on going down the rabbit hole until you sort of figure out the why. And that is really what we're looking for, is the why. Since this is not enough data and not enough time to really dig into the why, I'll show the process of cleaning up this data and a couple more tricks with PyPlot. So another thing we could do to really visualize it is what if we plot the average time that we already found, which is the seconds, against the average time per day to sort of set up a baseline. So we need an array. Basically every point needs another point to sort of reference to. So a quick way to do this is just create an array of seconds and then multiply by 7, because there's 7 average times per weekday. So we need 7 average seconds overall to create that accurate visualization. So you could see that this information got clobbered or changed or messed with before, so this is not the accurate data. Let's go ahead and close this out and rerun it. So now you can see that compared to the average, Thursday is much higher than average. That looks like 4,000 of a second's difference. So divided by 60, that's actually an hour between sales, the extra. So that's really bad. And there's a lot of reasons that could happen. Maybe competitors are running deals on Thursday. Maybe our customers, more customers are at work on Thursday from our target consumer group. There's a lot of reasons why, and those are some questions that could keep you going down the rabbit hole, but that's beyond the scope of this course. In this section, we're just going to be covering visualization. So another thing we could do is create labels for the X and the Y. So X label, we can call it weekday. Y label, we can call it seconds between. And run this one more time. So now we have seconds between in the weekday. And then we can also change this. A better way to do this, can you guess? What's a better way to plot this kind of data than a line graph? If you're thinking a bar graph, then you're right. That's a much better way to plot this, since a line graph is more about indicating change over time, whereas a bar graph is good for comparing averages. So let's change this to a bar graph. And for a bar graph, we just need to change the range. So it's essentially the same function. It's just plt.bar, and then the first is an array of the range, and then the second is the array of the values, or a list of the values. The third is the bar width, and then the fourth is setting the color. So using this, we can start creating what we have here, and let's set the bar width to 0.35 and set the color equal to green for the average time per day. And then we also have to change this to the second average to something similar. So we can keep this, most of this, and change the color to red. This is a small issue. Since we're making a fixed range, this list can't change. But with the bar graph, we need to change it because remember, computers are very precise. So if you don't tell it exactly what you want, stuff like this will happen. You can see that it just covers each other, and that's not exactly what we want, because it didn't make the assumption that we wanted to see all of our data. It just did what it's told and just overlaid everything on top of each other because that's what the commands were. They're very smart, but they're also very not smart. So we need to change, add something else called NumPy, which is basically a library that or a package that does a lot of nice data management for us. So there's a couple tools that are really nice. So there's a tool called Arraign. Arraign that makes a dynamic range that we can add stuff to. So this is where the bar width comes in. So we set how wide each bar is. So to set the red bar a little bit off from the other bar, we just have to add the bar width so that they're separated from each other. So it's the so if you imagine this bar width is 3, and then this bar width is 3, between it there's 4 spaces. Basically what's happening right now is the second bar is directly on top, which are periods, just for this example. So basically what we're trying to do is go to the second one and say, like, let's offset you by 3. So now instead of having them stacked on top of each other, they are nicely aligned. So that's basically what this function does, and it makes it look nice. So let's run it and see what happens. I didn't like my little drawing. So I believe this is where having Google as your best friend. Since programming is very precise, having documentation or just like manuals or dictionaries on hand is like really good. It's the same way if you have a spelling test, you want to have a dictionary with you. If you're taking the SAT or you're at work, or like you're doing anything, like you want to have some sort of reference. Since a lot of times programming work and computer work is mostly like in your room, you don't really have to have it on hand. It's not life or death. So it's mostly about, like, can you get the data processed in time? And there's no reason not to use a free resource that has all the information to help you get there and have everything in your head instead of just looking it up when you need it, especially now that we have smartphones in our pocket all the time. So it's actually Arraign instead of Arraign. So we can go ahead and run this again, and it looks like there is one more issue. NumPy AD Arraign is not callable. So we created the Arraign, and then we don't need to call it again since it's already created. So we can just go ahead and take out the second call, and then boom, our graph is fully done. We can add a title and seconds between sale on by weekday, and this way it'll be nicely labeled. And we can also create a legend. So we can create a label here. We just call the legend function, and then there's another item here called label. and then we can set the label to whatever. So the green, let's set it to average time per day. So average seconds per weekday. And then here we can say average seconds overall. So I don't like the color green for average seconds per weekday because it sort of signals change. So let's go with let's just go with blue for the average seconds overall. That way, green, blue, there's pretty neutral colors, so it doesn't really tell us anything. Whereas the red sort of indicates something bad, whereas the green indicates something good, and that is setting the wrong signals from our image. So looks like this graph is a little bit nicer. It's a little bit more neutral. Looks like the label and the legend are a little off, so we can just shorten this. But you can see at this point it's more of like design and art rather than actual science and math. So it's more of like trial and error and figure out what looks good that you can convey the information you're trying to say in a good way and an easy way. So for the person getting it, it's at this point it's all about imagery and all about communication, and that's more that's not covered in the scope of this course. So this is how you create the graph, and we can go ahead and just save this real quick. Just call it savefig and graph.png, and this will save it for something we can use in our spreadsheets and whatever we want to use this for. So if we open here, we can see that our graph is saved. I believe that's the right function. There we go. So we have our graph over here, and it's saved under graph.png that we can use in our spreadsheets or whatever. We can send it to investors, decision makers, and so on and so forth. So in this, to recap, we covered expanding our analysis stage and finding the average time between sales, and then presenting that information in a graph for key decision makers, or helping us understand our decision making a little bit more. If you're a solo entrepreneur, if you're working in a corporation, it's for decision making. Unless you are the decision maker, then it's just for your use. If you're using Matplotlib for any other issues, then it's just a nice way of looking at your data in a way that's easy to understand. So this covers the visualization portion of this of the CSV section. And if you follow along, in the next section, we're going to be covering saving our data and exporting it so we can keep it to look at later. And after that, we're going to be looking at some pitfalls and some other issues, and that should wrap up our CSV section. So stay tuned, and I'll see you in the next section. If design is something that you are interested in, you might be interested in a course that I am planning for the future called Design Based on Cognitive Science. Cognitive science is the psychology of the brain, the physical workings of the brain, and understanding how good design fits into that. Some examples of this is how to lay out information in proper ways that makes it easy to digest. Some principles of cognitive science, such as the differential, the being different principle, where something that is different is easily recognized compared to everything that's the same. This is very effective in advertising, such as if you have something that is very popular, it's easy to get ignored. However, the thing that's different is the first thing to be spotted. So in advertising, this is, you can see this, that if everybody's creating a commercial that's very similar, you create a commercial that's radically different, or a print that's radically different, that's going to be the first thing that gets attention. You can do a simple experiment to see that phenomenon right now. For example, if you have pencils in a holder, lay out all your pencils in a row, and you can see, you will see that all the pencils sort of look the same. But the moment you turn a pencil 9 degrees sideways, then that is the first thing your eye will fixate on, because the brain is designed to spot the first thing that's different. This is the way the brain that creates patterns, and is very similar to how when you walk into a new room and there's a weird smell, it shocks you at first, but after 20-30 seconds, your brain will adapt and phase out that sound. This is the same concept in visual arts. Your brain is naturally attuned to phase out stuff that's similar. So when you have something that's different, the brain will fixate on that. And that is a principle that you can use in your design to really draw attention. And those are all concepts and more that I'll be covering in my course, Cognitive Science for Design, or Design Based on Cognitive Science. So if that's something you're interested in, fill out the survey after this course and check it out when it's released.